Okay, in this video I'm going to introduce the formulas that we're going to be using to finish off the chapter. In the notes on Blackboard I've got a handout here, and this is for 7.5, 7.6, and 7.7. It's really just all the formulas that are there in the book in these sections, and I've indicated which section the formula group pertains to. I'll just basically what I wanted to do is just to kind of go through where some of these formulas are coming from. In the last section we had talked about establishing identities. Now we're going to be doing some of that here also. And now when it comes to identities, I mentioned this before, you only need to know a few of them, okay? It'd be a good idea to memorize the reciprocal identities, the quotient identities, and then the Pythagorean identities. These were all mentioned in the last chapter there, okay? Now there is going to be some other identities worth knowing in calculus, and I can comment on those once we get there, all right? So as I mentioned on this sheet, now a lot of these formulas really just come from the sum and difference formulas and then some algebraic computations to kind of gather up a bunch of these other ones here. So I was just going to show you where a few of these come from. Okay, we're going to look at the proofs of some of these trig formulas. Now, in calculus, you guys will be proving things from time to time. Okay, it's just part of the course, and so this is kind of an introduction to that. Now, proof, of course, is an argument that a mathematical reasoning indicating why something is true. So I was going to start with how about let's take a look at cosine of alpha minus beta. And so that would be equal to cosine alpha, cosine beta, plus sine alpha, sine beta. Alpha and beta are angles. Okay, and let's look at a proof of where this identity comes from. In this problem, I'm going to start with a circle of radius 1. And suppose that alpha is an angle that is bigger than beta. Okay. Then I'm going to also plot 2 points, which I'll call P1 and P2. P1 is going to have coordinates x1, y1. P2 will have coordinates x2, y2. Now, in this triangle that it would be forming in quadrant 2, resulting from angle alpha, if I were to compute cosine of alpha, well, cosine of an angle is adjacent over hypotenuse, right? So the adjacent side would be whatever that x distance is that I was going to the left, and the hypotenuse would be the radius of the circle. Okay, now the radius of the circle is 1, so cosine alpha would just be the same as the x coordinate there. Sine of alpha, well, again, with this triangle here, sine of an angle is opposite over hypotenuse. The opposite side would be whatever the y value is that was the distance that I was going to go up to get to point P1. And the hypotenuse, again, would be the radius of the circle, which is 1. So sine alpha would be the y coordinate there. All right, so instead of writing x1, y1, I'm going to look at the coordinates in terms of cosine alpha, sine alpha. Okay. Same deal with P2. Okay, P2 is this point resulting from angle beta that is, I positioned that in quadrant 1. And if you look at a triangle there in quadrant 1, okay, you're going x units, x2 units to the right, and then y2 units up. So with if I were to compute cosine of beta, well, that'd be adjacent over hypotenuse. The adjacent side would be whatever the distance x2 is. The hypotenuse is the radius of the circle, which is 1. So cosine beta would be my x2 coordinate. Sine beta, that'd be opposite over hypotenuse. The opposite side would be whatever that y2 value is that got me to point 2. The hypotenuse is the radius of the circle, which again is 1. So y2 would be the same as sine beta, right? So instead of writing x2, y2, I'm writing cosine beta, sine beta. Now in this picture, I'm going to shift these 2 points, P1, P2, and by the way, the angle that would be between these two would be whatever alpha is, you're subtracting beta, so that'd be alpha minus beta. And I need to be using alpha minus beta here in the problem in order to get that left side of the identity. Okay, now in this picture, I'm going to redraw this, but I'm going to redraw it in such a way so that point P2 is located right at the point 1, 0. Okay, point 1 is also going to shift as well. Okay, so this angle, alpha minus beta, is going to stay the same. I'm just simply rotating these 2 points and positioning them in such a way so that point P2 is now at the point 1, 0, which I'll call point A. Here's point 3, which would be the relocation of point 1 then, okay? The angle that would be between these would be alpha minus beta, just as it was the same here between P1 and P2. Okay, now if I were to draw a line from points P1 to P2 and draw a line from A to P3, that distance would be the same between those 2 points, right? Since I've really just rotated these 2 points to, have the 1 point there be at a different location. That distance is going to remain the same, though. So if I were to calculate the distance between A and P3 using the distance formula, I want the square root of the difference in the x's squared, which is what I've got there, plus the difference in the y's squared, okay, which is what I've got here. And then that's going to be the exact same distance as the distance between P1 and P2. Well, again, I'm using the distance formula, and I want to take the difference in the x's squared, which is what I've got there, plus the difference in the y's squared. Okay, I want the square root of that whole thing. Now, I'm going to square both sides to get rid of the radical notation there. And that's going to leave me with what I have underneath the radical then on both sides. And here's where the algebra is going to kick in. So on the left, I'm going to FOIL out cosine alpha minus beta minus 1 times cosine alpha minus beta minus 1. That would be cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1. And then this term I'm just going to leave as is. On the right, I'm going to FOIL out this guy here and then this guy here. Okay, so cosine alpha minus cosine beta times another cosine alpha minus cosine beta would get me cosine alpha, the quantity squared, minus 2 cosine alpha cosine beta plus cosine squared beta. Sine alpha minus sine beta times another sine alpha minus sine beta would be sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. All right, now cosine squared of an angle plus sine squared of the same angle is 1. So I've got those underlined here. 1 plus another 1 from these terms will give me 2. This middle term I'm going to keep as is. On the right, cosine squared alpha plus sine squared alpha, that is 1. Cosine squared beta plus sine squared beta, that is 1. Again, that's my Pythagorean identity. That's one that you need to know. So I've got 1 plus 1 is 2. And then these terms here that are non-marked, I'm leaving as is. You can subtract 2 from both sides. And so those terms are gone. And here's the last thing then would be to divide by negative 2 on both sides. Okay, and so what I have circled there is exactly the thing that I had to get to, right? So that would be a proof of where that identity comes from. Okay, now a lot of the other identities are going to fall out by what we have here. This is the most rigorous calculation. The other ones are not so bad. Okay. So we looked at cosine alpha minus beta. Cosine alpha plus beta, that's the same as cosine alpha cosine beta minus sine alpha sine beta. Well, cosine alpha plus beta, that'd be the same as cosine alpha minus negative beta, right? And the reason why I have written it like that is because now I can use the identity that I've already proven up here. Okay, so it's going to be cosine alpha cosine negative beta times sine alpha plus sine alpha times sine of negative beta. The cosine function is an even function, so cosine of negative beta, that's the same as cosine beta. Sine of negative beta, that's the same as negative sine of beta, since the sine function is an odd function. Okay, and so that's where I had to get to on the other side of that identity, right? Cosine alpha, cosine beta, minus sine alpha, sine beta. All right, another one in that group is for tangent alpha plus beta. Okay, well here's that, so that would be tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. All right, well let's see where that comes from. Tangent of an angle can be rewritten in terms of sine and cosine, and that's what I've done here. And we've got the identity for cosine of alpha plus beta, right? That was what I had circled over here, so I'm using that identity. And then there's the identity for sine of alpha plus beta. That's sine alpha cosine beta plus cosine alpha sine beta. Now, here's where I'm trying to get to. Okay, I need to get back to terms involving tangents. So with what I have written here so far, I'm going to multiply the top and the bottom by 1 over cosine alpha cosine beta, since I'll need a 1 leading off there in the denominator. Remember what I had said about establishing identities? You know, you're basically starting from one side and going to the other side. You're not solving for alpha or solving for theta or solving for x or anything like that. Okay. Any student doing that is missing the point of what we're doing here. Okay, we're just simply using some algebra and trying to manipulate one side to make it look like the other side. So here's what I've got. If I were to split the fraction into 2 that are in the denominator, cosine alpha cosine beta divided by cosine alpha cosine beta, that would be 1. And then minus sine alpha sine beta over cosine alpha cosine beta. Well, sine alpha over cosine alpha, that'd be tangent alpha. Sine beta over cosine beta, that'd be tangent beta. In the numerator, I'm also going to split this fraction into 2. Sine alpha cosine beta over cosine alpha cosine beta. Sine alpha over cosine alpha, that'd be tangent alpha. The cosine beta terms will cancel. And then on the second fraction, you're going to have cosine alpha over sine beta over cosine alpha cosine beta. Cosine alpha over cosine alpha, those will cancel. Sine beta over cosine beta, that'd be tangent beta. Okay, and so that's where that identity would come from. When I stop the video here, and I'll show you the rest of them in the next video.